All right, so starting with problem number 3, says Candace is wrapping a Toblerone chocolate bar for her sister's birthday. The box is a right triangular prism. The bases are equilateral triangles with side length 4 centimeters, and the box is 15 centimeters long. All right, so let's take just that much information and put it on the picture. Box is 15 centimeters long, so from here to here is 15 centimeters. This is the height of the prism. The height of the prism is always the length between the two parallel congruent bases. Here's one base, and the other base would be this one back here. The distance between those two bases is the height of the prism. Then it says we have equilateral triangle bases with side length 4 centimeters. So this is 4 centimeters here. This is 4 centimeters here. And this is 4 centimeters here. How much wrapping paper will she need? What am I asking about if I want to know how much wrapping paper it's going to take? Surface area, yes. So surface area for a prism, 2 times the area of the base, plus the perimeter times the height. When we had a question similar to this on the skills check, a lot of people were identifying this shape as a pyramid. A pyramid comes up to a single point up on the top. The triangles meet in a single point. On a triangular prism, the two triangles never touch each other. So the difference between a prism and a pyramid, in a pyramid, all of the triangles come together to meet in a single point, and in a triangular prism, those triangle bases never, ever, ever touch. All right. Absolutely. You're welcome. All right, so our bases are triangles. How do we find the area of a triangle when it is an equilateral triangle and all we know about it is the side lengths? What about 60? I like 60. 4 times 15? What are we doing 4 times 15 for? All right, so this capital B is area of the base. But that's not how you find the area of the base. 15 has nothing to do with the base. 15 is not involved in the base at all. The base is a flat triangle. The 15 is the distance between the two bases. But for this part, we just want the area of the base. So we need to be able to find the area of a triangle. How do you find the area of a triangle? We had 2 different formulas in 11A that we could use for this. Yep. We had 1/2 base times height for a triangle, or 1/2 AB times the sine of angle C, which is what we're going to use here because we don't have the height of these triangles, but I do have 2 of the sides, and I do have the ability to find the angle in between 2 of those sides, plus the perimeter times the height. And this is perimeter of the base. All right, so let's fill in what we've got. Surface area is equal to 2 times 1/2 times, what should go in for A and for B? 4. So times 4 times 4 times the sine of angle C, which is going to be the angle in between 2 of those sides. All 3 sides are the same size. which means what about all three angles? They're also the same. So to find the size of the angle, I'm going to take 180 degrees because the three angles of a triangle have to add up to 180. We're going to cut that into three equal-sized angles. What is 180 divided by 3? 60. So this angle right here is 60 degrees. So it's sine of 60 degrees plus the perimeter of the base. What shape is the base again? A triangle. How do we find the perimeter of that triangle? We can add all the sides. How big are all the sides? They're all 4. So we can do 3 times 4. 3 sides, each side is 4. We want the perimeter of the triangle base. Times the height of the prism. What was the height of the prism again? 15. All right, so let's calculate this in 2 pieces. I'm going to put just this first part in, the 2 times 1/2 times 4 times 4 times the sine of 60. What is 2 times 1/2 times 4 times 4 times the sine of 60?
13.856.
13.856. Plus, now back here we do 3 times 4 times 15. 3 times 4 times 15.
180 degrees.
Not degrees.
Just 180.
Just 180. And then we add those two together, 13.856 plus 180. We get 193.856, and that would be centimeters squared. How much chocolate is contained inside the box? If I want to know about what fits inside, what am I asking about? Volume. Volume for a prism is area of the base times the height. So the area of the base, how do we calculate the area of this base again? 1/2 AB times the sine of C. Yes, 1/2 AB times the sine of C times the height of the prism. So I would have 1/2 times 4 times 4 times the sine of 60 degrees times the height of the prism, which is how much? 15. Hold on just a second. My thing is not responding. There we go. Times 15. And I would just grab that entire thing and throw it into my calculator. 1/2 times 4 times 4 times sine of 60. Make sure you close the parentheses after the 60 before you multiply it by 15. Oh, you forgot to multiply by the height. That's just the area of the base. So then multiply by the height. What do we get?
103.923 centimeters cubed.
Yep, 103.923 centimeters cubed.
So what do you say we really need to know in order to solve problems like this?
Well, there's a couple things you need to know. A, You need to understand the formula itself, understand exactly what on the actual object corresponds to which pieces of the formula, because you need to be able to identify what are the bases and what is the lateral area. The lateral area is the perimeter times the height. That would be this part right here.
Right.
So these three rectangles on this triangular prism that I'm holding up here.
Right.
The bases would be the two triangles.
Okay.
It's important to know that because you're going to have to find the area of the base. So you have to identify what shape is the base, and the area of that base is what goes in for that big capital B.
Okay.
So in addition to understanding the formula and understanding what parts of the formula relate to which pieces on the object, you have to know how to find the area of different flat shapes like we did in 11A. You have to know how to find the area of a trapezoid. You have to know how to find the area of a rectangle, how to find the area of a square, how to find the area of a triangle like this one.
Okay.
Those formulas will not be given to you. I will give you all the volume and surface area formulas, all the new formulas I will give you. But I am not giving the area formulas from 11A that you need so that you can find the area of the base. You have to know those pieces. So if you don't remember those, grabbing your notes from 11A and looking at the very back of that packet would be where we wrote down all of those two-dimensional flat shape formulas.
Got it.
What else would you guys like to see? Number 4? Absolutely. Problem number 4. A pyramid in Egypt has a base with dimensions 150 meters by 150 meters and height 80 meters. Find the volume, surface area, and lateral surface area of this pyramid. All right, so it says we have base edges with dimensions 150 meters by 150 meters. So this right here is 150 meters. This over here is also 150 meters, which means in the back, this is 150 meters. And this side over here is also 150 meters. The base is a square. We also know the height is 80 meters. The height goes from the vertex, the point up at the top, straight down to the center of the pyramid. Let me write that just a little bit differently. Have 80 meters there. We want the volume, the surface area, and the lateral surface area. Let's do volume first. What is this shape again? A pyramid. What is my volume formula for a pyramid? Not 1/2. Remember, I'm giving you all the formulas, so it's okay to look these up. What is the volume formula for a pyramid? 1/3 capital B, because it doesn't just mean base. What does it mean?
Oh, area of the base.
Area of the base times the height. One of the things I want to caution you guys about, because I'm still seeing it happen, even though we're talking about it all the time, that capital B does not mean base. Like you just pointed out, it means area of the base. I have some people that are just grabbing a single number and throwing it in for the base. You have to calculate the area of the base. Every single time when you see a capital B, you are going to have to calculate that area. So you have to identify the shape of the base, and then how do you find the area of that base? What is the shape of this base? A square. How do you find the area for a square? Side squared. So I have 1/3 times side squared times the height. How big are the sides? They are 150. So I have 1/3 times 150 squared times what? Times 80. And then I grab my calculator, I pop all that in, and what do we get? $600,000, yes. And that would be meters cubed. All right, so that was one thing they asked for. They asked for volume. Then they asked for surface area. What is our surface area formula for a pyramid? What is our surface area formula for a pyramid? Yep. Area of the base plus, how do we calculate lateral area for a pyramid? How do we calculate lateral area? 1/2 perimeter times the slant height. So this is area of the base. And this is the lateral area. So that's what we're going to use for the third thing they asked. So we're going to calculate the lateral area as part of the surface area. You guys told me that the base was a square, and the way we calculate the area of a square is side squared plus 1/2 times the perimeter of the base times our slant height. Do we know the slant height? No. So we're going to have to come in and find the slant height. So the first thing I'm going to do is over here on this picture, I need to create a right triangle so that I can find my slant height. So I'm going to go from the center of the base, that's where the height hits, over to a base edge. Because my base is a square, how big will that segment be right there? How much? $75. How did you get that? You're absolutely right. Yes, it's going from the halfway point, from the very middle of the base, over to the edge of the base. So it's going to be half of our base edge. So half of 150 gives us 75. The slant height comes down a lateral face to the center of that base edge. So this is a right triangle. We're going to use Pythagorean theorem. A squared plus b squared equals c squared. What has to go in for c? Slant height, which is my cursive L. What goes in for a and for b? 80 and 75. So I have 80 squared plus 75 squared What is 80 squared? $6,400 plus what is 75 squared? 5625. We're going to add those two together. I get 12025 when I add those two together. Then we're going to take a square root of both sides. If you do it to one side, you have to do it to the other side. The squared and square root cancel each other out on the right. And our slant height comes out to be about what when we round it to 3 decimal places? 109 point, what was the decimal? 65, and I still didn't catch that last digit. 658. Remember, we always take it out to 3 decimal places. Always out to 3 decimal places. All right, so let's plug this stuff in. So surface area is equal to side squared. How big is the side of the base? 150. So I have 150 squared for the area of the base, plus 1/2 times the perimeter. How would I calculate the perimeter of that base? We're going to add 150 4 times. So 4 times 150, which would give us 600. Yep. Times the slant height, which we just calculated to be 109.658. All right, let's do this a piece at a time. What is the 150 squared? $22,500 plus our lateral area, which is just this part. What do we get from the 1/2 times 4 times 150 times 109.658? $32,000. What was the rest? 897. You said 0.4? I got 0.7 when I did it, but I'm not going to fuss about the decimal point. Did you get 0.4 or 0.7? Oh, you're not that far yet? You got 0.4? All right, then it's probably a typo on my part. And then we add those two together for our surface area. We get 55,397.4. All right, hold on. Let me type it in my calculator and see if I can figure out what's going on.
Yeah, my lateral area was the same as yours. It was mine was also. I had the same.
All right, yep, times 0.4. All right. I think when I did this on my answer key, I rounded the slant height slightly differently, and that's why my answer was just a little bit off. Just a little bit different. All right, so there's my surface area. They also asked me for what? Lateral area. The lateral area is just the part that goes around the base. So just that 1/2 perimeter times the slant height. So I would have 1/2 times 4 times 150 times my slant height of 109.658. Which we already stuck into the calculator one time. And when we did that, we got 32,897.4 meters squared. I will not give you separate formulas for lateral area. I will give you the volume formulas right here, and I will give you the surface area formula right here. You have to know on the surface area formula what the different parts of that formula mean. You have to be able to identify what is the lateral area from that formula so that you can calculate it on these problems. All right, what else would you guys like to see?
11.
Number 11, absolutely. What'd you say? Yep. Number 11. A rectangular box contains 3 balls which lie flush against all the sides. What does it mean again when it says they lie flush?
They fit snug.
They fit perfectly. They fit snugly. So there's no extra room. There's no gaps and nothing is bulging. Fits perfectly. The volume of one ball is 14.137 cubed inches. What is the radius of one ball? Well, the only thing they gave us to work with is the volume, right?
Yes.
So what formula am I going to have to use?
Volume.
Have to use the volume formula. Volume for a ball. A ball is a what? A sphere. Volume is 4/3 pi r cubed. And we are going to take that volume of 14.137. We're going to put it in the place of the V, because that's where our volume goes. 14.137 equals 4/3 pi r cubed. And we now need to solve this for r. First thing I want to do is get rid of that fraction. How do I get rid of the fraction? We can multiply by the reciprocal, or to get rid of just the fraction part, I can just multiply by the denominator if I want to, and then we can get rid of the numerator separately. It is fine to multiply by the reciprocal. It's going to take my 2 steps and cut it down to 1 step. It's perfectly fine to do it that way. Yep. So I'm going to multiply both sides by the denominator. So I'm going to multiply by 3. Over on the right, when I multiply by 3, that does nothing to my numerator. It does not change that 4 at all. The only thing it does over on the right is cancel out with that denominator. When things cancel out, they do not affect any other piece. When you have those 2 pieces canceling out, nothing else gets affected by that. All right, so then we have to do 3 times 14.137, which gives us what? 42 point, how much? 411 equals 4 pi r cubed. Then I would want to do what? Yep, divide by 4 on both sides. What is 42.411 divided by 4? 10.602 equals pi r cubed. I got to bring my work around here. 10.602 equals pi r cubed. What now? Divide both sides by pi. What is 10.602 divided by pi? .374 is equal to r cubed. What do I have to do to get rid of the cubed? Cubed root. Remember, if that was a squared, we'd be doing a square root. To get rid of a cubed, we do a cubed root. What does a cubed root look like?
I don't know.
Yep, looks just like a square root, except in the front right here, it has a little 3. Same thing over here. If you do it to one side, you got to do it to the other side. So normally when we do this, we say that squared and square root cancel each other out. Well, here where I have a cubed, the cubed and the cubed root cancel each other out. Do you guys remember how to do a cubed root on the calculator? All right, so the first thing you have to do on the calculator is tell it what the root is that you're going to do. In this case, it's a cubed root. So the first thing you have to do is put in the number 3. So we type in the number 3. And then you push second and the caret key. That's going to take your 3 and make it a little 3 in front of the radical. And then you put in the 3.374. And what do we get? 1.499. Do we need units on that? Inches. It's equal to our radius. So that means on one of these balls, from the center to the edge, it is 1.499 inches. Or I could go from the center to the edge this way. There's no reason why I have to go left and right. I can go up and down. That would still be 1.499. Part 2 of the question, part B, says what are the dimensions of the box? So dimensions of the box, I want the length. I want the width. And I want the height. I know that from the center to the edge for one ball, it's 1.499. So how far would it be to go side to side through the widest part of one ball?
Multiply by the radius.
What are we going to multiply the radius by?
2.
Yep, double that radius. Tell me what you get. 2.998. The ball right next to it would be how wide at its widest point? 2.998. And the third ball? How wide would the third ball be? 2.998. So for the length of the box, I'm going to do 3 times 2.998. And what would we get? 8 point what? You said 994? 8.994 inches. All right, that's the length of the box. What would the width of the box be? Yep, 2.998. So we would have 2.998 inches for the width. And what would the height of the box be? 2.998. Inches, yes. All right. 13? Absolutely. Absolutely. So same page, just down at the bottom of the page. Cameron bought a birthday gift for his friend Jay. Jay has placed it in the box pictured below. How much room is there inside the box for the gift? If I want to know about what's inside, what am I asking about? Volume. Tomorrow on the test, it is fair game to word questions like this, and I cannot tell you whether that is volume or surface area. That is one of the things that I will be assessing is, do you know that volume is the space inside and surface area is what covers the outside? What is this shape? Rectangular prism. So volume equals area of the base times the height. What shape is the base of this prism? It is a rectangle. How do we find the area of a rectangle? Yep, so I'd have length times width times the height for my volume. What are we going to put in for the length and the width? 5 and 10. So I would have 5 times 10 times, what is the height? No, height is 2. You could have done 5 and 2 as the base, and then 10 would be the height. You can decide how to orient this. When we're talking about a rectangular prism, because every single face is a rectangle, you can decide which ones are the bases, but the bases have to be parallel and never touching. So what we went with was that this was the base. So then we had our length and our width, and then the 2 centimeters here is the height. What do we get when we do 5 times 10 times 2? 100. So the volume would be 100 what? Centimeters cubed. All right. How much wrapping paper will Cameron need to wrap the gift? What are we asking about now? Surface area. surface area for a prism is 2 times the area of the base plus the perimeter times the height. You guys told me that this base was a rectangle and that we're going to find its area by doing length times width. So I'd have 2 times length times width plus the perimeter of the base times the height of the prism. So surface area equals 2 times 5 times 10 plus, now I need the perimeter of the base. So let's come over here and look at this base. I shaded in orange what we were calling the base here. I need to find the perimeter of that. So one side is 5, one side is 10. How big is this side over here? 5. And this side here is 10. So the perimeter is 5 plus 10 plus another 5 plus 10. We didn't go up the height at all. Now, if you had looked at this as the base, then that's what you would be finding the perimeter of. What is 5 plus 10 plus 5 plus 10? 30. So the perimeter that we're going to use here is 30 centimeters times the height, which is what? Height is 2. All right. So we're going to do this in 2 pieces. What is 2 times 5 times 10? 2 times 5 times 10. 100. So the area of just my 2 bases is 100 centimeters squared. And then we have plus 30 times 2, and I know 30 times 2 is 60. So what is my total surface area here? 160 centimeters squared, yes. Yes, you will still get the same answer if you use something different as the base, as long as you calculate the perimeter of that base correctly and the area of that base correctly. You should get the same answer. Yes, it does not matter. Now, if it's not a rectangular prism, the bases have to be the 2 congruent shapes that are parallel, that are never touching. If you have triangle bases, it cannot be a rectangular prism, and the triangles have to be those bases, with the distance between them being the height. What else would you guys like to see? I have enough time for a short one. 14. I do not have time for 14. I did go over number 14 in first period, though, so that is on the video for first period that will be posted around lunchtime.
Okay.
At the very beginning, problem number 2?
Yeah, I don't understand. I don't understand why the square is the cylinder.
So what we're doing here, we're looking at problem number 2, and this is perfect. We're going to rotate it around that line right there. So this point, when I rotate that stick, is going to stay right there attached to the stick. And this point right here is also going to stay attached to my axis. But this point right here is going to rotate down to right here. And then it's going to rotate back up like this. This point right here is going to rotate down to right here. And it's going to rotate back up like this. And this edge right here is going to rotate down in between those two. Do you see the 2 circle ends? The 2 circle ends with the straight sides in between mean that this is a cylinder. We have something with 2 circles on either end. That would be a cylinder. The triangle here, if I take the triangle and I rotate it around that axis, these 2 points are going to stay stuck to the axis. But this point right here is going to rotate around and then back. And this edge right here is going to follow it. It's going to rotate. So I have a circle on one end and then this like triangular shape. What do we call it when we've got a circle base like that? A cone. And if I were to take this circle and rotate it around the axis, what shape would I get? A sphere. All right. So as I already mentioned, I will be posting my videos throughout the day. First period, I did go over problem number 14, and I went over several other different problems. We went through problem number 1 in detail in first period. Answer key is already posted in Canvas. All right, so on Canvas, if you scroll all the way down, right here is where the videos will be posted. They'll start going up around lunchtime as soon as first period gets done rendering, and they'll go up throughout the course of the day until I get all 4 of them posted. Down at the very bottom of the page is where the solutions for the test review are posted, and they have all of my work. All of my work there. Be turning in this test review tomorrow. This will be the next to last thing that you guys turn in for me.